Welcome back to the Peggy Smedley Show, the podcasting voice of IoT and digital transformation.
Welcome back to the Peggy Smedley Show, viewers. We are coming to you live from Liveworx in Boston, and we are on Periscope. I'm here with Joe Barkai. Hello, Joe.
Hey, Peggy. Good to see you.
Well, you know what? There's been a lot going on. You've been on a I guess you had your own session today, right? You've been busy. So you just came back from Croatia. Is that what I just heard?
Yes, I was in Hungary, then Croatia.
You've been a busy guy. You know what? That's what a wanted consultant has. Very busy, right? Analysts doing busy things.
Absolutely. And, one of the perks of doing this is you learn, about new people, new cultures, new places. It's awesome.
Well, I think that is amazing. Well, look, we have got a lot to talk about right now, so let's talk about all the amazing things that here. You've known about PTC and what they've been doing for a very long time, so I'm sure you've had a chance now to kind of talk and understand really what's been going on in this space. I guess I'd get your take on a little bit what's been going on in the factory space right now. A little bit, give me your take on what factories are kind of doing right now. Are they spending enough time? I know you gave a talk. Tell me about your talk. Let's talk about what your talk was about.
Sure. So the talk was about manufacturing today and in the future, and what is the potential impact of technologies around robotics and artificial intelligence of the factory of the future. So I'm trying to really understand what technologies such as those that PTC is working on, what is their role in the factory of the future. So we think about the factory of the future, and I often use the term, not my term, but the term lights out factory. So that was part of my talk today. What does it really mean to experience a light out factory?
What does that mean, lights out factory? Help me understand that definition then, because that's even a new one for me.
Right, okay, so the slide I used was totally blank, dark. So the point is, we are trying to get to the point where factories do not need human labor anymore. So it's all done by robotics. So robots get instruction directly from the CAD system, like a PTC CAD system, feed them into manufacturing systems, into robotics, and out comes a product at the end. So we save, well, obviously we use robots to improve quality, improve throughput and so on, but we also save on lights, on air conditioning and so on. But we often use this as in kind of a template, if you will, and we say there are going to be two living creatures in the factory. One is a dog and one is the man. The role of the man is to feed the dog. The role of the dog is to make sure that the man does not touch the automation. So that's a lights out factory.
So when we think about that, we know that there's a lot of, I guess, how do I put this, there's a lot of impact on machine learning when we say that. How do we look at what's happening and give us examples of the machine learning? Because when Jim was up there and he's talking about putting together what the future is going to be, and we talk about artificial intelligence and all of these different things, is machine learning going to be a part of this digital transformation that we're talking about when we talk about AI and people try to understand how is machine learning going to be a piece of this whole digital transformation that he described today when he gave his keynote?
So machine learning is already part of this transformation. And of course, it's not the only technology. As you may remember, I grew up on AI in the previous wave of AI, where we were unable to commercialize neural networks and machine learning, but we use other technologies. So it's really part of a kind of arsenal of tools that we have to create autonomous intelligent systems such as robots, such as autonomous vehicles, and so on. But today we put more focus on learning, whether it's self-learning or supervised learning, because the tasks are very, very complex. It's very difficult for us to create algorithms and predefined processes and scripts for every plausible scenario. So it's the part of the future is self-learning systems. Having said that, there are still many, many challenges perhaps we are not sufficiently aware of in terms of what are the difficulties in machine learning. And it goes beyond just the need for more data. We often hear conversation about, okay, we need more data. The more data we feed into a machine learning system, the better it becomes. And no, this is hardly accurate description, because with so much data comes responsibility, come issues, come biases, and so on. And one of the things that you no, I really care a lot about biases in human beings, society, and in how machines that learn from those biases.
So when you say those biases, what does the average manufacturer understand about those biases? What do they think about those when they're trying to figure out how that's going to impact the way they go to market?
It's a great question, because when we often talk about biases or the difficulties in achieving data for self-learning data, often in the manufacturing space, in the industrial space, the concerns are about a lot of data. We need a lot of data. Or data is not clean, it's dirty, we need to cleanse it. No, I think the problem is much more profound than that, and I'll give you an example that comes from outside the manufacturing. I find it useful sometimes to bring examples from outside for people to say, oh, we never thought about it. So, not far away on the other side of the river, there's a professor in the Harvard School of Government. Her name is Latanya Sweeney. She has nothing to do with manufacturing. She's School of Government. A long time ago, she Googled her name. Like we all do that, but she did it for research. And when she got the Google results, you know how Google provides kind of services? Do you want to know this or that? So the ads that came back were Latanya Sweeney arrested. Latanya Sweeney, would you like to know about her arrest record? No need to say that she has no criminal record, of course. So she used this as an opportunity to research how Google, and as an example of a tool, provides information that gathered from self-learning. She found out if one has an African-American sounding name, and of course she's African-American, he or she's 25% or so more likely to be served information about arrest records. So two important observations here. First off, the tool was not wrong, the tool was right. It's a very kind of ironic statement about the state of the data. It's true, again, it's a fact, it's a very sad fact, but it's a fact that there are more African-American sounding names in arrest records. So the tool, the self-learning tool, did what it was trying to do, look at trends and report on the trends. So now we have biased data that was created by biased individuals and biased society, fed into a system, and it delivers, it amplifies the bias forward. And that's a very, very dangerous thing not to know, I guess. And it's not only social biases. And by the way, it happens also with gender biases. Amazon had to, quote unquote, fire its recruiting system because turned out it was preferring males over females. Again, it was repeating facts. If you look at technology jobs, there are more males in these jobs. Therefore, the tool concludes, I should better assign a male to this position. But it's the same true for statistical biases and other biases that exist in data. So often I get the question, so why can't we cleanse it? My response is, the data represents our biases, therefore we're not always aware of these biases. We don't see the biases because we're the one who created them.
Well, we've seen in society a lot of biases as it gets worse and worse every day, right? So that would only make sense, right?
Exactly, so these tools amplify those biases. At the same time, potentially, we can use now these tools to expose those biases and do what we need to do, not at the system level, but at the society level, to correct these biases.
So how do we then, if we understand those biases or things like that in the tools we have, how do we then use other tools? Let's say, going beyond just what you described there, how do we use other things like predictive analytics or predictive maintenance tools? How do we then start to advance other tools that help us make our lives better on the factory floor? Because if we're using tools that we sometimes are misusing, let's say, because it's biases that we have, how do we then use tools to actually improve the way we're servicing for predictive analytics, predictive maintenance? How are we advancing the way we're using things on the factory floor? Are we starting to use those even more to be even servicing our customers maybe in a different way, in a more maybe efficient way?
I think part of it is really understanding the outcome of those tools. And there are kind of multiple threads of thoughts here. First off, some of these AI algorithms are very difficult to understand in the sense that they cannot explain the rationale. In other words, in traditional programming, you have the input and you have some sort of a function or algorithm and output. And if you have two, you can always know the third. So if you know the input and the output, the algorithm, you know the output. Conversely, if you have the output and the algorithm, you can reverse engineer the input. Not true in many of these machine learning systems, which is why, again, it's going to be very difficult to understand the biases. So this is one element that we need to worry about, the unexplainability of AI. The other part, which ties more, I think connects more to the conversation about predictive maintenance, there's a different problem here, which is the difference between individual systems and instances and the entire install base. Very often we hear about predictive maintenance and say, here's a system, we'll model the system, we'll create the digital twin, right, of the system, and we will detect anomalies, and then we kind of monitor the entire field and figure out what's wrong. What we need to remember that, especially in mechanical systems and hydraulic systems and so on, no two systems are alike, even when they're off the manufacturing line. They may be similar, but there's still a lot of tolerances built into them to begin with. Let's even say we somehow figure this one out. Once these assets are put into service, they start going in different directions. Example that I often use is 2 trucks that roll off the assembly line. Again, they're not the same from day one because they have options and so on, but let's say they're close enough. One truck now does coast-to-coast long haul, the other one is doing urban delivery, short routes. One has an excellent driver, the other one does not. One is well maintained, the other one is not. These systems from day one start changing. It's very difficult for these algorithms to adapt to the changes. They don't understand, if you will, the reason for the changes. So one of my concerns for many of these systems is that they do not understand the difference between kind of the lab environment and the wild. And they don't understand the life cycle of those systems. And therefore, they are very easy to, relatively, I guess, easy to build a prototype of and create a proof of concept. It's very difficult to put them in the field, which I think is in part why wide adoption is still behind our hopes and expectations.
When we look at what are some of the, I guess, when you look at things right now, are there things like that you've seen that have been cutting edge solutions right now? Are there any cutting edge solutions that have impressed you?
Yeah, I'll tell you about some of the interesting work that is being done, and it's cutting edge, but it's very practical. We talk about robotics. So improving of imaging systems. System allows robots to look at parts, understand orientation, and understand dimension, and know how to align them and grab them and to the next task is very important. You know, instead of having to lay out parts and system and subsystems on an assembly line in a certain orientation, a robot can go into a bin and grab a part and move on. So that's very important. It really reduces a lot of human labor necessary today. This leads to another area that is kind of experiencing some progress, is around tactile sensors and gripping systems. It's funny, or it's interesting, how we're doing a great job in robot dexterity. They're very flexible, they're very dexterous, they do a lot. They are not as good in gripping and grabbing stuff, because the robot has to know the weight of the part, they know how hard it can grab. Is the surface flexible, so you don't need as much force, as slippery and so on. So gripping system will be another area that is being developed. Looking at robots overall, we're doing more and more work on collaborative robots, or cobots. Robots that not only know their task, but know the tasks around them. The robot then knows the role of the human, so robots can work safely with humans. Today, most robots are behind protective shield. We're looking more into robots that can not only be safer because they have sensors, but also they know what the human is about to do, and therefore it's more kind of aware, it's situational awareness, and the robot then can collaborate with the human more. We'll see more and more cobots and collaboration getting closer and closer to lights out factories.
We've been seeing the cobot concept of this now gaining in momentum only because of what's been happening with the factory floors, is we've been having less workers. Do you see that increasing, or do you see that out of necessity, or do you, as you were saying, because of that, or do you see because it's cost effective?
Well, it's all of the above. I mean, we need to augment human labor because human labor is expensive, because we don't have enough qualified workers. Parenthetically, we can also discuss about, will this kind of drive job loss? But parking this aside for a second, we need to augment human labor and do it more effectively and more safely. But it's not only static robots, it's mobile robots. And you can even, by extension, look at this as being part of the autonomous car situation. Right. You know, how do cars relate to other vehicles? two obstacles on the road, two humans. How do we, in a way, they are collaborative robots.
But aren't they going to take away some of the mundane tasks, the tasks that humans shouldn't be doing? They should be doing things that are more creativity, that the things that humans should be dedicating to, and the mundane tasks that you were just saying, things that the robot, right now, the gripper, it's like picking, apples off a tree. Right now we see that, but more light things that the robot has to learn to do. It's not doing the mundane task you want, like picking a tomato right now. Maybe it's not doing as well of a job because it doesn't know which ones are the best ones to pick or whatever. In time it will get better at that, I guess. Those are the things, because those are back-breaking tasks.
Right. So those jobs will go away first. I mean, jobs like this, mundane, labor-intensive jobs will be first to go. Same for other services. And, so we talk about automation, it's not only robots, you can think about process automation. So jobs like, dispatchers and bank tellers that somehow are still with us, and I think travel agents and so on. So
Flipping burgers,
Right.
I mean, you're going to we start seeing Flippy the Burger or whatever his name is. We're starting to see that.
Although I think that we err on the cute side, because if you want to have a robot that flip burgers, it doesn't have to look like a humanoid. I mean, we still like those images of a humanoid like a robot flipping burgers. We need to change the cooking method to make it easier for the robot. But yes, these jobs will be the first one to go.
So when we look at all of this right now, talk to me a little bit about, just the idea of what Jim was talking about today when we see CAD and PLM and the convergence of the ability to actually use VR and AR, and the ability to now be able to interpret and see things and use what he was saying when we see things now in a factory, and the ability to bring all of that information together to be able to interpret and bring products to market. When you're bringing CAD and PLM together in ways now to bring a product to market, the ability to alter that product, to bring a product design and manufacture it faster, quicker, easier than ever before using IoT, how does that change time to market, the costs? How does that change just in general manufacturing in the scope?
Well, the ability to experience the product throughout its life cycle is the key element here. So how do you experience a virtual product in its intended environment? How do you compare the performance of the product for different demographics? So again, we don't always do a good enough job in relevant product understand different genders, female versus male user, tall, short people, and so on. So this allows us to experience all of these things in advance. Now, it could diverge and not go all the way into manufacturing if we want to go into lights out manufacturing. The reality is probably somewhere in between. Much more of this will be in the early stages, in the design, in the concept, in focus groups, and so on, and continuous feedback. I often say that the IoT connected products with and without AR gives you the best ever focus group, continuous focus group. You always get feedback and you can modify it immediately. If through CAD and PLM and generative design, which is another AI topic we did not talk about, we can understand user feedback without the user actually feeding back, but seeing experience and immediately provide better customer experience, better product, better quality, higher safety, greater compliance, and do most of it in silica, without ever having to bend metal or pour plastic.
So when we look at generative design, like you were saying there, are we thinking things now in all of this, that in manufacturing, in the whole idea of what we look to the future, what we've looked at in the past, are we seeing things that's going to take a whole new generation of engineers to bring us to the future?
Probably, although I don't think it's such a binary thing as if the existing engineers cannot handle this. It's true that the new generation of engineers not only are more open to this technology, and they expect more technology, their thinking is different. They tend to think much more realistically, much more collaborative. I think that one area that I see that I like in new engineers more than perhaps others is their openness and ability to collaborate, which older generation did not like. So it's a culmination of technology and an affinity to technology and collaboration, and then using the tools in a more effective way. So for me, the tools really drive the advantages of the younger generation of engineers to do a better job in designing, in adopting and personalizing products.
Where are these products going to be created? Are they going to be created in CAD? Are they going to be created in a whole new, are they going to be created in, a new product? Will it be the traditional PLM product that we're used to? Where are all of these new designs? Is it going to be in an IoT solution? Where is all this going to be, like the way we used to do it all along?
That's a good question. Maybe there's a difference between will they or should they, which they're not quite the same thing. Should they? Yes. Will they? No. Now what will happen? We'll continue to use CAD, and CAD will get maybe a broader definition, and CAD perhaps will be more geared towards design to manufacturing or design to market. So we'll have less transition between the CAD phase and the output. And in a way, the old concept of BOM perhaps will slowly go away, in part because it's an artificial gateway, and we don't want that. We want to go directly from design to 3D printing. So the BOM, traditional BOM, may have kind of redundant role here. We still have to have BOM because of primarily traceability and compliance. But we want the BOM to be a bit more sensitive and flexible.
So when we think of building information modeling, and the way we're looking at that form is what you're saying, right? That's what you're referencing. So when we look at that, that's going to change things. You think that might be changing?
That should be changing, and not so much in building, although perhaps in building as well, but if you think about mechanical systems and so on, the increased number of software and software-driven components brings opportunities because a lot of the end product can be defined later in the process. So the more software-defined functionality you have, the more you can defer the decision about what this product will do and how much will it cost and who is the user. And we see more and more software in products. So it means less physical manufacturing, more software and configuration management that happens later in the process. So that's good in terms of adopting product for demographic and market and so on. It puts a lot of pressure on existing PLM because the BOM, the bill of materials, is not built to support software and flexibility.
Building materials, okay, the building materials
bill
that
of
you're talking
materials,
the
right.
bill of materials you're referencing in these cases.
Yes.
Okay, so all of the bill of materials that you're saying, and all of these that have to do with all the products that are being produced. Okay, so go ahead. So as you look at all of these that come through, and we look at all of the bill of materials that have to be produced, how will then that'll change? So you're seeing all of this maybe changing, maybe not, but who will be in charge of it? Do we know?
Well, the default assumption is the brand owner or the label owner owns the entire process. But you're right in the sense that we'll have more and more fragmented manufacturing, if you will. The supply chain will slowly change. We'll have more kind of modular manufacturing, which each portion or sub-factory or maybe some entire factory will provide one part of the value. So different parts of the manufacturing process will be implemented in different places, and you'll try to defer the final assembly, if you will, or the final software configuration till the very end. A lot of the manufacturing perhaps will not be done by the brand owners. Today, most manufacturing is still very verticalized, even take automotive, where the supply chain provides most of the value. OEMs still control a lot of the value and a lot of the process and specification, especially with Japanese OEMs that also have equity role in some of these suppliers. But over time, we'll be able, because it's all software driven, we'll be able to actually fragment or federate manufacturing and defer the final assembly until the very end. And the role of IoT there is really to provide the visibility. I have perhaps a little bit of an extreme view about IoT. IoT in itself is not an end, it's a means. It provides the visibility, it enables the digital thread, it provides the conduit from the context of making right decisions. But in itself, I don't see this as being the goal.
So depending on wherever you are, whether you are creating whatever type of product you're creating, whether it really doesn't matter, because in the end, however it gets out the door, the shape of whether it's a building information materials that we said or a bill of materials, whatever is ending at the end, how it ends up is going to change based on the IoT, how in the end, how IoT defines it.
Right, and
or
it goes,
digital transformation.
Right. And it goes both ways. It goes downstream all the way from the design until delivery, but also continues to monitor the product as it's working, how the product interacts with the users and the environment, and feeds the information back. So in so many ways, IoT closes the loop that PLM always promised. PLM always promised to have complete loop. PLM always promised to front-load decisions, but we were unable to do it because once the product leaves the factory, we lose visibility to it.
Will the sales start filling into all that?
It should, because if I have positive sales experience or a negative sales experience, I want this to be fed back and in context so I understand why. Why did the customer not buy this option? Why did the customer opt for different configuration? I want this to be on record, if you will, to be feedback and say, okay, what is it? And create a very rich context. It's not only the machine context, it's the entire context. Who is the customer? Who is the competition? What was the geography? And create this rich context to make better decisions.
Then that is the entire digital transformation.
Exactly.
All right, well, Joe Barkai, I've enjoyed spending time with you. Where can our listeners go to learn more about what you're doing?
Well, I write a lot in my blog, joebarkai.com, as simple as joebarkai.com, and looking forward to hearing from people.
All right, there you have it. All right, you've seen we've been coming to you live right here on Periscope. You can tweet at us at ConnectedWMag. We're going to take a quick hour break, but we are going to be back coming to you live from here from Periscope. We'll be back at 3 p.m. Central. So as always, you can tweet at us again at ConnectedWMag. This is the Peggy Smedley Show, the podcasting voice of IoT and digital transformation. Remember, with great technology comes great responsibility. We'll see you back here in 1 hour.